more of theory, you can say. And along with me, Dipshika is going to be helping me with this as well. So today we're going to be covering a little theory, plus Dipshika will be walking you through an a data set that's already worked with. Dipshika, you want to say hi?
Hi everyone, I'm Dipshika. I'm in second year AI and I'll be a co-speaker along with Trisha. I'll be taking you through the walkthrough for the bad drivers dataset. Yeah, that's it. We can continue.
So, now, what is data science? Usually when people say data science, they and it's something that they haven't heard of. They think it's about creating models or making all those fancy visualizations and writing lines and lines of code. But in short, data science is all about making impact. And how this impact is created, it's by making insights based on the data that's given from different places and surveys. Wherever there's data, you collect the data, and at the end of the day, you want insights. So, and there's also data products and product recommendations. So, based on data that already existing, you want to survey that over and over again and check what is the best possible outcome that you can get from this data to answer a specific question. And the way that you create this impact is by making models or data visualization and writing code. So next slide, please. Okay. So earlier we used to have only limited and well structured data in the form of records and register. The problem with this was it took lots and lots of physical space, as in it needs to be written on paper, and there could be like error, a lot of space for human errors. So now the internet is just forming with pools and pools of data. So there's an abundance of data, and it can be either structured, unstructured, or semi-structured. So basically, you've got the real world, which is what the yellow globe signifies, and then you derive the raw data from there. And following that, you have the process and analyzing that data, and now you're filtering it out to get data that actually means something or meaningful data. And based on that, you give the useful insights that businesses and different companies need. And simply put, data science is merely a 21st century extension of mathematics that people have been doing for centuries. It's a skill of using information to available to gain insight and improve processes. And what makes data science different from traditional statistic is that it not only tries to explain the values but also to predict future trends. Now, next slide, please. Now, the people, as the word says, the people who do data science are your data scientists. So, this is only a part of what they do, but they're expected to collect a huge amount of data and transform it to a usable format. And this is using whatever they've gotten, they're going to solve different problems. Data scientists are also expected to be working with a variety of programming languages like SAS, R, Python, and things like that. And it basically, data science lies in the intersection of both IT and business. So they're expected to be communicating and collaborating with both worlds. And the best part about this is every day in the life of a data scientist, they're looking for order and pattern in data and spotting trends that can help a business. Okay, now moving on to your applications. So first we have security. Now, uh, this this just focuses on cyber attacks. So there's not only the problem of hackers, but there's also the how of the cyber attack. Now let's look at the problem of hackers first. Now it's not just us, but hackers are using more and more sophisticated techniques, including artificial intelligence, to perform these cyber attacks. So they're using um, they're using machine learning and data science to their advantage, and they can use the same strategies to automate processes for finding the business and agencies most susceptible to their attacks. They locate the weak points within different networks and develop new criminal technology to sidestep on organizations existing security system. That's the first point. Now, the second point, the how of an attack. So, traditionally, antivirus and different scanners are focused solely on discovering what that threat is to cybersecurity, and then they eliminate the threat from the network. So, with modern applied data science, there's also a focus on the factors leading up to the hack, on the attack, as well as the actual characteristics of that attack. Now, moving on to the next point, the change and growth of big data. Now, there's always an abundance of data out there related to cyber attacks, not just cyber attacks, in general, anything. And with this plethora of data, it can be used in many different ways. So, the rate at which this data both multiplies and transforms makes it so difficult for an average cybersecurity tool, not like not only us humans but even a cybersecurity tool, to keep up with this ever growing data. So using data science, we can sift through this data, filter it, and make the best use of it. Now moving on to the next application, sports. So I'm not sure if you heard of this movie called Moneyball. um, But this movie is a perfect example of how data science is used to in the field of sports. So in simple terms, predictive analysis is what is done with data science in sports. So there can be player analysis. So we can improve each player's game on the pitch and their fitness level by analyzing their training pattern, diet chart, etc., and revamp those with insights from our analysis. And then we have team analysis. So using the team stats, we can build state of art models to figure out the winning combinations with their probabilities. And then we've got fans management. So we can find patterns and form clusters or group with different algorithms based on and run campaigns for those targeted groups. So the management can be focused on improving the aspect. So it's to basically keep renewing your fan base. Moving on to the next one, finance uses finance. So finance covers the aspect of risk analytics. Every company has some risk while doing business, and it's become essential to analyze the risk before taking any decision. Analyzing the threat has become a crucial for large companies for their strategic decision making. Okay, now this is a brief about just learning data science with Python. Some of the libraries that we'd be using is NumPy, which is it just provides a way to work with your arrays and different derived objects like matrices and things like that. And there's also an assortment of routines for fast operation on arrays. Then we've got pandas. So when working with tabular data, such as data stored in spreadsheets or databases, pandas is what is the right tool. So it will help you explore and clean and process your data. Then we've got matplotlib, which is used for visualizations, and Jupyter, Colab, Crestle. These are just different IDEs that we'd be using. So for this session and for tomorrow's session, we're going to be using Colab. Okay, now coming to data science, the process. First off, we've got data collection. So this is just a process of gathering and measuring information on different variables of interest. So it's a systematic, excuse me, fashion that enables answer stated research questions, and it tests the hypothesis, evaluates different outcomes and things like that. Now there's different methods on how data can be collected. First, you've got primary data or secondary data. Under primary data, there can be statistical methods, surveys, polls, interviews, focus groups, etc. And then you've also got secondary data collection methods like financial reports, sales reports, government reports, the internet, the biggest secondary data source for data collection. Um, Coming to the next step, data organization. So what you do in data organization is, as the word suggests, you'll be categorizing and classifying data to make it more usable. So it's similar to a folder, a file folder. And most of your time in the process of data science will be spent in data organization. Yeah, now the questions that should be answered here would be: is it scalable? Two, is it flexible and customizable? And three, is your application future proof? Which means as the technologies keep getting better and better, would your data and the data that you have used and organized, would that be able to adapt to the ever changing technology? Also, inclusive of data organization, you've also got data cleaning. So that takes pretty much 68% of the process. Now, coming to the next and the final step, exploratory data analysis, or also known as EDA. So, this enables deeper data analysis as patterns and trends are identified. Now, the most essential steps are variable identification, univariate analysis, and bivariate analysis. And the tools can be used to begin acquiring knowledge of your data set. It can help cut down a massive data set to something that's more manageable and where you can focus your efforts and your time on analyzing the most relevant data. And it's conducted using a combination of both automated activities, which helps you give you an initial view into the data and understanding the different key characteristics. And then you've got manual activities where you're filtering the data to identify anomalies or patterns. Now, Dipshika would be taking over and having a walkthrough over the data set that she's worked on.
So, is my screen visible? Can someone
That's
confirm?
visible.
So yeah, hello everyone. I'm Dipshika, and I'll be taking you through a walk. I'll be taking you through a walkthrough that I've prepared with basic analysis that we do. So here I've taken a very preliminary data set which can be found on Kaggle. So y'all can download it from here. Now in Colab, we usually have to upload the data set. So yeah, we're waiting for it to upload. Okay, so yeah, it's uploaded. So now we'll be importing a few libraries that are that, as Trisha mentioned earlier, that are important for functions and operations that we do here. So pandas and numpy is for operations related to your data set, and seaborn and matplotlib usually help with the visualization. So let me run this. Okay. Now we load the data set. So we create a data frame and then we do pandas, that is the PD that is the alias name for pandas, pd.read CSV. So it's basically reading the CSV file, and then we do df.info, which will give us everything that's there about the CSV file. That is how many entries are there, how many rows, how many columns, what are the columns, and then how many non-null values are there, and what are the data type of each of the entries stored in each of the columns. And yeah, so there are 8 columns in total. And so for the first column is date, which is a categorical value, and the rest of the 7 columns have numerical entry columns. So there's number of drivers and so on. Now we do df.head. This will display the first 5 rows of the data set. So here we can see there are 8 columns, and the first 5 rows of the data set, the first 5 entries of the data set have been displayed. Now df.tail will display the last 5 entries of the data set. So yeah, head and tail have respective functionalities. Now we do df.shape, that will return that how many rows and columns are there in the data set. So there are 51 entries, 51 rows, and 8 columns respectively. Now we can see here that the columns are in sentences, and it's while plotting or while doing any functions, it will be difficult. So for ease, we rename the columns, and we do df.info to check if they've been replaced. So yes, they have been replaced. I've replaced, okay, state is just a word, so that's there. And number of driver fatal. So it is number of drivers involved in fatal collisions. So that's how it's been reduced. And df.describe will provide all the statistical information that's there on the data set. So which tells us mean of each column, and then number of entries or count, that is number of entries, that is 51, and mean of each column, each entries in the column, and then standard deviation, minimum value, the first quarter percentile, the half 50 percentile, 75 percentile, and the maximum value that is stored in the each column respectively. So now we check if there are any null values in the columns. Before we checked it during df.info also, that there are no null values for all the columns. So yeah, we just rechecking it using isNull function. Now we go to the data visualization part of the analysis. So here I've made use of the libraries Seaborn and Matplotlib. So let's see what happens. Okay, so now this is a regular scatter plot between the insurance premium and the losses to insurance companies. So I'm using a line plot, which is there here. So defining the X and Y axis and giving the data as data frame, because previously we have stored it here as data frame. Yeah, we've stored it here as data frame. So yeah, df. And defining the X label and Y label, giving a title. And yeah, so this plot basically gives us an insight that we can see that as the car insurance premium amount increases, the loss incurred by the company is greater. So let's say the insurance premium is like $1,300. So the loss incurred by the company is around 160. So higher the premium, higher the loss. Here also we can see it's $1,300, and the loss incurred by the company is around $200. So we can see that the higher the insurance premium, the higher the loss incurred by the company. Now we do another scatter plot that that compares the drivers state-wise in fatal collisions. So yeah, we've defined uh, X and Y, X and Y axis. So there's person speeding, which is X axis, there's 20%, 30%, 40%. And Y axis is state. So all the states that are stored are here. And data is again data frame, and X label and Y label we've defined it, and the title is given. So so here we can see for each state they have mentioned how many percent of drivers are involved in fatal collisions while speeding. So in most states, there are two insights that we get from here. That in most states, the speeding contributes to 40% or less of the total fatal collisions occurred. So 40% is this. Now we can see that after 40%, there are very few compared to before 40%. So yeah, this is one of the insights that we get. The other one is Pennsylvania and Hawaii are the two states that have speeding costs 50% or more of the fatal collisions. So we have Pennsylvania here and Hawaii here. So these two states are said to have more than 50% collisions because of speeding. Now we check another plot that is a bar plot that shows us the top 10 cities that are states that have the highest percentage of contribution of collision because of the alcohol, like drunk driving. So yeah, so the state that tops this list is Montana, and it shows the top 10 list that caused accidents due to drunk driving. And now we have another bar plot that shows us the top 10 states that had accidents when the driver was not distracted. So there's District of Columbia that tops the list. So accordingly, we can plot more graphs and get more insights and slowly walk towards our goal that we need. So yeah, this is a starting step to a data analysis and exploratory data analysis. We'll be sharing the notebook with you so that you can get better insight. Yeah, are there any questions?
Yeah, hello. My name is Samrit. I actually had a question related to what you just said. So you showed like a plot that like the more the insurance, then the more the losses. The more the losses in like the more car accidents happen. I think that was one data which you showed. So my question is, when you're doing data analysis, can you make up assumptions like that if you increase, like from the plot you showed, like if you increase the insurance premium, then the accident rates will also increase, because it could also be a coincidence, right?
Yeah, it could be a coincidence, but then a coincidence wouldn't occur so many times. And yeah, about the statement that I said that the higher the insurance premium amount is, greater is the loss that is incurred. You're talking about this plot, right? If I'm right? Okay, Samirit, is it? So yeah, with regards to your question, I hope you've asked about this plot. So yeah, only a few entries might have coincidences, but when you see a plot and there's a clear increase in the a clear increase, so you can see it's clearly increasing linearly. So that's how you come to a conclusion that okay, the as higher the car insurance premium is, the loss incurred by the company is also higher, because that's how it's increasing linearly over here. If you can see, even though the data points are scattered, but you can see there's a clear linear increase in the uh, line. If you plot a line here, so there's a clear linear slope. So yeah, by that you can conclude that okay, the losses incurred by the company is directly proportional to the car insurance premium. So higher the premiums, higher will be the loss incurred.
Okay, okay, but there is always a chance that that might not be true also, right? Like it could be a coincidence also. That's also a possibility, right?
Yeah, sure. I mean, that also depends on your data set. So
Hmm.
until and unless you plot and find out what kind of a trend it's following, you won't be able to like conclude anything precisely. So yeah,
Hmm.
I hope I've
Okay.
answered.
Yeah, yeah. It is answered. Thanks.
Thank you. Any other questions? If you guys, if anyone wants me to explain a part again, I can do that if You guys want me to? So apart
Yeah,
from, yeah,
actually, I also had a doubt related to this thing, a primary source of data and secondary source of data. Could you explain that part again?
which part?
Yeah, no, it wasn't here. Like before this, before you started explaining, Trisha like was talking about primary source of data and secondary source of data. I Yeah, so she was saying the internet is a secondary source of data. So I had a doubt related to that. Like how is it an like what do you mean by secondary source of data?
Okay, so primary source of data is basically like things where people have a direct interaction, like
Hmm.
surveys or polls and different things like that. And secondary source of data is where things are just out there without any order, and it's up to you to, it's not authentic, and you don't know if it's true or not.
Hmm. Okay, but yeah, but like suppose can we always say that the internet is a secondary source of data? Like sometimes it could be primary also, right? Like
Well, I mean, both of it is there, so it's both primary and secondary.
yeah, okay, got it. Thanks.
It's so vast and there's no order to it. That's why it's usually put under secondary source.
Ha, yeah, got it. Yeah, okay, thanks.
I think we can wrap up for today. Yeah. See you guys then. Thank you.
Thank you for joining.